to my YouTube channel, where every episode I take a physics topic and try to explain it in a really simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. This episode describes half-life. Now, this is all to do with radioactivity and nuclei decay. Basically, half-life is the time it takes a radioactive material to lose half of its radioactivity. Let's start with the fact that radioactivity is a totally random process. Random! Radioactive substances give out radiation from the nuclei of their atoms, no matter what. Radiation can be measured with a Geiger-Müller tube and counter, and this measures count rate. And the count rate is the number of radiation counts reaching it per second. Because radioactive decay is totally random, you can't predict which nucleus in a sample will decay next, or when any of them will decay. But you can calculate the time it takes for the amount of radiation emitted by a source to halve. For you. And this is known as the half-life. This half-life can be used to make predictions about radioactive sources, even though their decays are random. And also the half-life can be used to find the rate at which a source decays, ergo, its activity. Activity is measured in becquerels, where 1 becquerel is 1 decay per second. That was such a quick download of all things radioactivity.
Download.
So one of the headlines for radioactivity is that the radioactivity of a sample always decreases over time. Each time a radioactive nucleus decays to become a stable nucleus, an alpha or beta particle or a gamma ray is emitted, and this means that one more radioactive nucleus has disappeared. This means that as the unstable nuclei disappear, the activity of the source, so the number of decays in a given time, will decrease. So the older the sample becomes, the less radiation it will emit.
I remember when I used to decay like that.
How quickly the activity decreases can vary a lot depending on the isotope. So some isotopes may just take a few hours before nearly all of the unstable nuclei have decayed, whereas others could last millions of years. Hurry up, would ya? But, and there's always a but. The problem with measuring activity is that it never reaches zero. So this is why we had to use the idea of a half-life to measure how quickly the activity drops off. So here's the important definition of half-life. Let's remember it. Half-life is the time taken for the number of radioactive nuclei in an isotope to halve. In other words, the half-life is the time it takes for the number of radioactive atoms now present to decay. It is also the time taken for the activity, so the count rate, to halve. So a short half-life means the activity falls quickly because the nuclei are unstable and decay rapidly. Samples with a short half-life are dangerous because of the high amount of radiation they emit at the start, but luckily they can quickly become safe. Whereas a long half-life means the activity falls more slowly because most of the nuclei don't decay for a long time. The source emits just a small amount of radiation for a long period of time, so it just sits there, creepily, unstable, biding its time. And my last nice little fact is that for a particular isotope, the half-life is always the same. Quick example time! The activity of a radioactive isotope is 720 becquerels. 6 hours later, it's falling to 45 becquerels. Find the half-life. Right, so initial count is 720. After one half-life, so divided by 2, it's fallen to 360 becquerels. After 2 half-lives, it's 180. After 3, it's 90. So after 4, it's falling to 45 becquerels. If this happened across 6 hours, then the half-life must be 6 hours divided by 4. So the half-life is 1.5 hours. You can also work out the half-life by a graph of activity versus time. So activity's on the y-axis and time's on the x-axis. Like I said at the beginning, the activity can be measured by a Geiger counter, and we can plot this on a graph against time. The curve will always look like this, and this is an exponential curve. Exponential! To find the half-life, choose an activity level on the y-axis and draw a line across from it until it meets the curve. At this point, draw a line straight down until it meets the x-axis. Then, halve the activity count chosen and carry out the same exercise to find a new point on the x-axis. The difference in these two lines on the x-axis, so these 2 points in time, is the half-life. Thank you for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I will try to do a video for you.